This is Suzuki Swish 2015 model, 125cc. Because of the carburetor problem, uh, this vehicle will frequently turn off and it has to be started again and again with self. That's why the lead acid battery will go bad very frequently. So I made this 8.4 ampere hour 8.4 ampere hour lithium ion battery pack, which is having 12 cells, 12 18650 cells in 3S configuration. That means 4 and 4 and 4, 3S configuration, and 3S for 25 amp BMS, which is only used for charging and balancing. Then discharge happens via a pack of 7 diodes, which I will show you. Each diode is capable of carrying 10 ampere hour current. The battery is each one is having 2800 mAh with 13C rating. That means 13 into 2.8 Ah is the discharge capability of each cell. I got them for 60% of the price. 60% of the price because they are 2022 manufactured battery, which were left in stock without purchasing from Robo Kits India. Robo KITS kitsindia.com for 60% of the price. They are manufactured by Molicel, MOLICEL. So that 3-year-old stock they were giving for 60% of the price. This battery I've used in drill machine also. It is quite good. I made this pack, which I'll show you, with BMS diode pack, some capacitor that I'll show you and all. See, the self is working. See, in single self it will be starting. And I checked with multimeter that when I increase the throttle, this voltage is increasing also. That means from 12.4 to 12.5 and all it is happening. So that means the charging is also working fine. But it is like somewhat dangerous cell because there is no fuse here. In case there is a short or because of vehicle crash or something happens, it's going to be big fire. Because it is 8.4 Ah and very high discharge and all. So I have used this protective film, polyamide tape and barley paper and all to make the insulation. I'll show it to you. This is the battery which I showed there. It's not in final form till now because the vehicle manufacturer has given exactly this amount of space in the footboard. So while pressing this the case, the covering, plastic covering for this, in case of this battery, this capacitor, which is I made a polar capacitor out of 2 non-polar. You can check online how to do that. That means connecting the negative ends together. So each is 4700 microfarad. So it will come out to be 2.3 millifarad, 35 volt. Back to back if you connect, you can make. And that is connected to the output of BMS, the output terminal. So this thing is creating problems, so I'll have to put it somehow here. Extend this cable and put the capacitor here. So this is the diode which I was telling. 7 diodes are there. You can check my previous video for how it is done. While discharging, this diode will come into play. While charging, the BMS will come into play. These are the balancing resistors Here is 3S 4P configuration. The cells are very good. Moly cell 13C and 2.8 Ah each one. Very high discharge rate. But only thing you have to be careful is when you are turning the vehicle, if you are somehow accidentally keeping it on, the vehicle key and all, this whole thing will get discharged without any check, because discharging is not happening via the BMS. It's happening via the diode. So you can damage the battery if the cell voltage goes below 2.5 volt. It happened like that in my previous build of the battery pack, and I had to redo this again. This is the tester which I made. It is having some 11 halogen lights of 100 watt connected in series. Parallel. So overall 77 ampere it will take. So this battery pack I tested with that. First time when I connected, some here, I think in the positive terminal some smoke was coming. Here this nickel strip was getting heated up and some smoke was coming, so I had to put 2 strips here. So after building this pack, some tester is okay. Some 80 amps tester should be there to test the capability of this before installing it. So I will keep on updating. So I have put this here so that when this sits here, the top will be free. This capacitor is here, 2.35 millifarad, 35 volt. Main purpose is to save this board from of the capacitor is to save this board from fluctuation, negative voltage spikes. It is the sick cat actually. Now he is recovering. Yeah. So it is put across this 2 terminal. Lot of solder had come, and when I was soldering it shorted also. Luckily I could remove it. So this 2 capacitor wires are here. Then the output is also from here. Now I've put it there and it is like okay. So if any problem comes while running the vehicle or later on, I will let you know. This thing costed me some 4,000 rupees, Indian rupees, as on November 2025, 4,000 Indian rupees. And that too when the battery is only 60% of the original cost. See, this kind of separation is very essential of the terminals, because these terminals are made up of very high conductivity material. They are contacts. In case they short together, certainly they will stick and you will ruin your pack at the minimum. There will be fire or something like that. So you can tape it while building the pack, and only after separating it like this you can remove that tape. I had ruined one pack by keeping the terminal hanging and exposed. These are like this tape. It's called Kapton tape, or polyamide or polyimide or something like that. Tape. Very useful. That Fisher paper I have used. Each of these 4 packs. That means each of them in the series. Each of these 3 which are there in the series. The 4, each of them are packed in this green color Fisher paper. Then the whole pack is put in Fisher paper. Then it is soldered, and also rings are put. in the positive terminal. Here you can see that helped in soldering. The unwanted solder will not reach the wrong place in the battery to cause short. So this Fisher paper and polyimide tape both are essential for building such battery. So this is 8.4H. Yeah, so I'm putting it back after finalizing everything. Whether charging, discharging and all work is working. One bad thing which happened was, as I told, there was some short when I was soldering this positive and negative terminal. The negative terminal, lot of solder was there, so it flew onto the positive one. But short was there, so momentarily, which I removed immediately. So you have to be careful. You cannot put lot of thick wires in this small board, but the wires have to be sufficient, otherwise this 70-80 amps cannot be drawn. So this much thickness, 1 square mm wire has to be there minimum. I have put 2 extra 0.75 thickness wire also. Then this is 10 mm wide and some, I don't remember the thickness of this nickel strip. That is easier to spot weld and even solder. You have to, like, if you keep the strip like this, from the edge you have to connect the strip as well as the battery. Solder has to flow on this edge like this, connecting the strip as well as battery. Otherwise you have to use spot welding like that. So I'll fix it up now. So it is a very restricted case they have provided. Good thing is there is no metal here inside, so there is no possibility of short. Restricted battery compartment, that's why I had to make it like this without any spacers or anything. Only this Fisher paper is the spacer between the battery packs. I have installed it and I tried it also. It will be closing, no problem. One click self only it started. These two wires I have connected to a cigarette lighter port in this seat, inside the seat, so that I can charge the battery in case of emergencies, and also use it to charge mobile phone and other things, and monitor the state of the battery also. It's always better to have this kind of thing with a fuse, this kind of socket. I'll just pack it now. I check the voltage. Now it's 12.4 when it is off. When I raise the vehicle after turning it on, it's going up to 12.5 and all. So this kind of paper I have put, Fisher paper, because there was some gap, so there should not be any movement in either side, otherwise some contacts may go loose. I have fitted it. This kind of zip tie I have used because these threads have these screws have plastic threads, so to repair that I put this zip tie, cut piece of zip tie. Any problem then I'll update. Okay, this is a cigarette lighter I was talking about. Cigarette lighter socket. It has multi-purpose, including making fire. One thing you have to be careful is that this should not be washed. Only after removing the battery should you do the washing. So put proper floor mats and regular inspection. Main advantage is this battery you can keep the scooter standing for a long time. This battery will not discharge. Its life will not degrade. Life will be at least 3 years compared to 1 year you get in the lead acid. Cost is like 4 times than the lead acid battery. Any problems I will update. I had put it in another scooter of mine here, but there is no space restriction here, but the metal casing is there. That is a disadvantage, but you can have build a bigger pack and put it here. So I left the key accidentally on for 3-4 days because my cats were sick then. I accidentally left it on, then the battery cells got damaged. So this thing is tested in this, but not after riding and all. So after 1 week or 1 month I will give you the update. See, this bracket is put now like this. So from below, from now, that keys which you press, the 2 buttons, grey buttons, are now covered. Yeah. So conclusion is you cannot get the fuel without turning on the vehicle in this car model, and I don't know whether it is risky to turn on the vehicle with the petrol line to the engine disconnected. Yeah. Testing this battery pack. I will tell you what configuration it is with this 877 amps tester. To hold the camera also with one hand. This is a positive terminal. Some smoke will be coming out from here, you can see. So I have to put double this nickel plated strip here. So after testing with this one, both this strip, one negative plate is there, and here is the one positive plate, both are smoking. So I have to double the this thing, strip here, put 2 strips here instead of just one. So it is like a 24 battery configuration. Each battery is 2.6 AH with probably maximum 3C discharge to use for vehicle. So as in my earlier video, this diode is connected from the negative plate of the BMS, negative output of the BMS, to anode to cathode to the negative terminal of the battery pack. So they are here. The configuration is 3S 8P. That means 24 batteries are there. Cheap batteries. That's why pack is more. Because my scooter has this particular scooter has capacity to fit this much, these many batteries. So 7 10 amp diodes are there. This is like 4700 microfarad capacitor connected back to back to make it into a non-polar 2.35 millifarad capacitor at 35 volt. After testing with this load, it is clear the smoke is coming from this positive plate which goes to the BMS below this, and the negative plate which goes to the BMS here. This goes to 12.6 volt point. This goes to 0 point volt. Yeah, so this thing has helped me to modify this one. This I will be using in a 110cc motor, scooter. Okay. Not scared. There is some debris here. This is like PVC plate, PVC pipe, sheets made up of PVC pipe. And above this BMS also, it's a 3S 40 amp BMS. Purpose of BMS is just for charging. This charging will happen through diode, directly to the battery. When charging, capacitor is there for protecting any spikes. And this is the positive point of the BMS. And BMS, the positive terminal of battery and positive point are same. And negative point I have brought it here from inside the BMS like this. This is the negative point. So now I have to remove this BMS and then double these two things, these two plates. Otherwise, when using in vehicle, it will heat up and damage some insulation, or may become corroded fast. Okay, I'll update. The earlier one which I had made was working. That was like 2.8 ampere hour battery. Each one having 13C on discharge rate. That means 35 amps. Each one having 35 amps. Here each one will have around 2.6 into 3 maximum. There it was 2.8 into 13. So there only fewer batteries were used. 12. Here 24 are used. I'll update on that. See, while making this battery, an important observation. When I connect the load across the positive terminal of the battery and this point, you can forget about this line, this point which is coming from the negative of this BMS. Positive of BMS is same as positive terminal of battery. Negative of BMS is connected here, then this diodes are put, and then anode to cathode, it is connected to the negative of the battery. So when load is connected between the positive terminal and this point, which is the negative of the BMS, the current is divided is also going through the diodes as well as the BMS. So that's what I have observed. So this BMS which I am using is 3S 40 amp. This thing I did not observe in the 3S 25 amp BMS which I had used. It looks like BMS is providing a lesser resistance than this diode. So some current is going through that as well as this, because after connecting this load, 80 amps load, these transistors are getting heated up. And since it is 40 amps and this is 80 amps load, that means the current is also going through this also. This thing has not observed in the previous battery which I made using 3S 25 amp BMS. This is 3S 40 amp. One thing I noticed was when I connected the load between this positive and this point, That is the negative of the BMS. The earlier battery, this positive terminal was showing some smoke, so I had to reinforce with another strip. But here, positive as well as this negative strip, which is coming from the BMS, negative of the BMS, which is below this board, with this brown board, was heating up. This thing was not happening in the previous battery which I made using 3S25. There only this one was smoking. I reinforced this and it was okay. But here this also was smoking. That can happen only when the load is connected between here and here, and the current is passing like this as well as through the BMS below this and through this strip. So when I put this, reinforce this with another strip, it is getting heated, but now smoke is not coming even after 15 seconds of this 80 amp load. That is one thing. It's better to use BMS in which the discharge path, that means the BMS resistance should be lesser, should be more compared to this diode resistor which is connected in parallel. Otherwise the current will split between the two, and that BMS may also get damaged sometime. Then the whole charging circuitry will stop. BMS gets damaged when discharging is happening, then charging circuitry also goes off. So I will not use this BMS. I will use the 25 amp BMS because I want the current to flow through this diode only, like it happened in the earlier one which I had made. So I'll replace the BMS. Otherwise the BMS may get damaged sometime. And I want only the diodes to take the load. Yeah. So all this thing came to picture only when I saw that this negative strip which is coming from BMS below this 0 point of the BMS, 0 V volt to the battery, this was also getting heated up. But the current, all the load I was expecting to pass through this, then this should not get heated up. Via the diode it will go, then this will not get heated up, but it was happening. So that means current is divided between this and the BMS. Yeah, so I made that modification to make sure that while charging, this is a positive end, this is the negative end of battery, positive end of BMS same as the positive of battery, negative end of BMS is connected to this line, that is this point. So while discharging, the current will flow through the load from here to the load, negative end will be connected here, positive end here, current will flow like this and to here, and it will go through this 7-10 amp diodes, 10 ampere diode, and go to the negative end of the battery. Earlier it was going through this diode pack as well as the BMS which is below this parallelly, but now I have added this diode. So the flow from BMS, it is below actually, connected to the negative of the BMS. Flow from BMS to negative end of battery will not happen, only diode will be used for discharging. While charging, anyway this will not work. While charging, the current will flow into this positive and come out through the negative end. It will not come through this diode pack, but come through this diode to the BMS which is there below this. Yeah, so I verified it. While discharging, that means when load is connected, only this diode gets heated up, not the transistors below this BMS. These transistors, they will not get heated up, and while charging only the BMS will be in place. So this is the configuration I need. Connected capacitor also. Now only I have to pack it up properly and connect the output terminals. So all because of this getting heated up, I discovered I found this issue. Yeah. So all this was possible because of this 80 amp load. Because testing has to be done while making the pack to make sure that current flow is properly happening while discharging and as well as charging, and then any smoke and all is coming, heating is happening, all that way. It is good to make this kind of pack, which I have showed in one of my earlier videos. And this can be discharged and charged one time before installing in vehicle to check the whether everything is okay, the capacity is as you have configured it. Sometimes this lot of problem was faced putting this solders, especially in the positive end of the battery. If you have spot welding machine, it will be good. There's a lot of solder will go like this. Let's say half of this 250 gram has been used, 125 gram at least has been used in soldering. This 24 batteries on both sides. Yeah, I'll update. Yeah, I've packed that battery properly from all sides using this Kapton tape, and then put the capacitor, diode here, BMS below that extra diode which I told, to ensure that discharge, only charging is taken care of by the BMS. Now this one is getting heated up when I run this charger at, it is running at 6 amps. See, sometimes that amperage varies. I don't know why. I'll just test it with load and then charge it once and then install. While testing with load, the cutoff point I have to manually keep note of it. Should not go below 2.7 volt for each parallel cell. Because now BMS is not there in the discharge path. This thing proved very useful. I'll keep on updating. I'll put this connector and all with the terminal, this kind of round terminal. Like here. Yeah. Discharge test using 100 watt bulb, and after 3 hours it has some 7 or 6 ampere hour, 6 amperes load is there, 100 watt bulb. Definitely 18 Ah capacity is there. We go up to 9, it will be even more. 18 Ah is confirmed. Should be 20.8 ideally. So discharge test done. There was some problem in fitting, so I removed this whatever sticker was here. Then I flattened this solder. One wire was going from below this diode bank, so I removed that and put it up and flattened this. So now this is going into the vehicle properly. Now that heat, this Kapton tape is there. This part should not touch, melt or heat up and touch the vehicle. This part is okay, this is negative. Here all the negative electrodes are there, the negative terminal is there. Positive is coming from this side, here. With this diode, this side if it touches, it's okay. This should not touch to the body of the vehicle. I checked the charging as well as discharging with this bank. I think things are okay. This capacitor is there, then lot of nickel plates are there, multiple of them are there. Anything beats up, maybe they will cut off. There is some short circuit or something here. And capacity is good, as I told last time. So I'll install this in the vehicle. This vehicle has good position and good capacity for fitting battery. That's why I could put this 24 cells. Otherwise 12 cells are only possible. So even though this thing which is supposed to be in the vehicle, this is slightly bigger than that. Length is almost same, but still slightly larger. Even height is slightly bigger. Not all vehicles this can fit. This is like 20.8. That means 2.6 into 8 is 20.8 Ah. This one brand new, if it is there, then it will be 3 Ah. This can deliver like 60 amps on paper. This will also deliver 80 amps only. This will last for a very long time. Even if you are not using the vehicle, this will get bad within 3 or 4 months of not getting used, even if it is a brand new battery. So there is more energy density, number of charge discharge cycles are higher in this, and it is like more what you call energy density, charge discharge cycles. And the self-discharge is less in this. That is a major advantage if you are not using the vehicle for a long time. But cost-wise, this is at least 4 times than this one. And there is a risk of fire also in this. If this gets involved in a crash or some short circuit happens, risk of fire is there. But still, there is one fuse is there, inbuilt fuse in the cap is there. But if that cap goes, then you should not use the battery. As I told, for the charging part, there is a diode here. That means from the negative of the terminal to the BMS, there is one diode here, which gives around 0.3 volts drop. That I put, as I told, to make sure that BMS is only used for charging, not discharging. Diode pointing from negative of the battery to 0 volt point of the BMS. So sometimes I am facing charging problems. That means it will show that it has become full, even in 12 volts. Then sometimes at 12.3 volts. Don't know because of diode or what. Now it is charging okay. Once it shows full, that it is full, then this charger and another charger I tried, it will refuse to charge it. That means BMS is blocking it. What I have to do is, for a long time I have to put this kind of 100 watt bulb, this kind of 100 watt halogen bulb, then it will start charging. For some 10-15 minutes I do. That thing I am facing one problem. Don't know exactly why. Okay, now also it is not showing the charge is happening. See. That is some problem here, I think. See. Okay, that was some problem with the connector here. AC connection here. In vehicle it should be okay. Only thing, it should not overcharge the battery. For that the BMS is there. So this is very basic pack having 3C battery. 3C ordinary lithium ion 18650, which is used for torch and all. That's why I had to use in 3S 8P configuration. Okay, I'll keep on updating. Now it is fitting in the vehicle, so no problem. I just have to install it. Testing on all has been done. See, this is what the circuit diagram is like. This is the BMS board connected to the battery pack. This 3S 8P configuration of 18650, each one having 2600 mAh at 3C. Okay, so you have to understand this 12 and this 12, this one, and this one are connected. But for 0 and 0, the connection is through a diode, not direct wire. Here the connections are through wires. Okay, and here you can connect load or charger. Okay, for this is the discharge diode here, 10A 10 diode, that is 10 ampere diode, 7 are there. Here 1 is there. So when charger is connected, so one thing is there that BMS will have that logic for overcharge protection, undercharge protection, short circuit protection, overcurrent protection, and overcurrent protection. So these 4 protections are there in the BMS, and also it will do balancing. 5 features are there. So when I am connecting the charger, you will be aware that BMS, this positive, this is the output of BMS. This is the output as well as input terminals of the BMS. When charger is connected, this will act like input. So you must be aware that BMS plus and this plus point are connected. That means there is no logic between the positive point and the positive point where this battery pack is connected. Okay, and this negative point and this 0 point are not directly connected. This logic for these 5 things which I told: charge protection, overcharge protection, undercharge protection, that means discharge protection, short circuit protection, overcurrent protection, that means more than 40 amps, and balancing. All that logic is here. Between this negative point and this 0, that means in the negative path all this logic lies. Okay, when you are charging, the current comes here. This is connected to directly here. It will come here, go through the 8 volt in the pack, 4 volt point in the pack, 0 volt, and while charging it will go here, and this charging protection, all that logic will come into play. While discharging, that means when the load is connected, it will go through this positive, it will draw current from the positive, it will go to the load, come out to the negative, and then the 7-10 ampere diodes are there. It will go to the negative of the battery. Then similarly it will go here like this. From here it will go out. That means while discharging, only the battery is involved, not the BMS. So that if you connect the diode alone, that will not work, because this also has resistance which is comparable to this. So if this was not used, then discharging was happening through here as well as through here. So this diode is used so that the BMS does not discharge, is not used for discharging but only for charging. Why? Because this BMS were going bad when the discharging load was done on this. That means the transistors in the BMS MOSFETs were going bad when the load for running the self motor of the vehicle and all were used. That is the whole purpose of putting this discharge diode, so that the BMS is only used for charging functionality and other functionality, but not for the discharging. So that's why this diode is used, to make sure that discharge only happens through this and not through both of this. If this is not there, the MOSFETs in this were getting heated up. Okay. So disadvantage of this configuration is, if you keep some light on in your vehicle, or even if you keep the key on, then slowly it will discharge. This battery will go down below the threshold, and it will damage the battery. I have a battery which is used in this bag, same manufacturing one, which I purposely discharged to 0 volt and then charged it. And after same period of time, this battery was giving, each cell was around 4.16 after some 1.5 months. But in that battery which was discharged to 0 volt, it was giving some 3.8 volt. That means the internal discharge will happen faster in the battery which has been misused and discharged below, we can say 2.7 volt or 3 volt, you can say. If you discharge it purposely or accidentally, that battery will not store charge, it will self discharge faster. That is confirmed, I saw in that. And between these two terminals I have added one capacitor with value around 2.5 millifarad, because many people were reporting that when the vehicles alternate, you can say the rectifier regulator of the vehicle, it charges this BMS, charges battery via this BMS. There is some spike and all coming. That means positive, negative are reversed or something like that, and spikes are there, then this BMS gets burnt out. Some people were telling in the comments of YouTube. That's why one capacitor has been put across this. That is what you see here, the bulge. Yeah, then this battery will go bad if it is over discharged. If there is some water which is flooded in water, or short circuited, or such kind of spikes and all come, then it will go bad. Otherwise else it is all okay. This is the third pack which I made. The first pack which I made was damaged because I kept the key on, and this diode discharged it to 0 volt, and the fuse cap, the cap fuses, they went off. So I've installed that battery. The details are written. Made sure that this metal holder which is there on the top is not touching the metal parts in the circuit. It looks messy, but it was easy to install. Then put this zip tie, single zip tie, secured it to the frame so that this does not come out. This is a positive terminal which has been wrapped. Negative terminal is exposed because body is negative. I have checked everything except for self. That I'll do because the carburetor is missing. So I'll remove that something which is there and then check it. Okay. So now there is capacitor here, and this is the earlier one which I had installed. Case and all is fitting. Light is all working, LED light. So I'll update. Yeah, I've installed the battery and packed it up. It's slightly difficult actually because all plastic are there. So carburetor air filter I have removed for cleaning purpose. I am removing this thing. Just give a self and show you. Okay, so battery is very well. I tried it some 23 times now, giving self. So this is the second time I am building it for this. The main thing is key should not be kept here. It should be removed and kept out, hanging when not using the vehicle. Otherwise battery will discharge. Okay, thank you. See, after 3 weeks of using this vehicle heavily, that means almost 10 kilometers daily, I'm checking the battery. So this is a cigarette lighter connected to the battery inside this footboard. It will carry some 1 amp charge, 1 amp current it can carry. This is a special attachment for the cigarette lighter socket, the male of that. Then this type of connector is there, and then the charger. So if you are connecting the charger and it is sending current inside, that means the BMS is fine. Okay, and then self is also working, so that means battery is okay after 3 weeks. I'll show the self. See, I have disconnected this thing. This light is on because it is connected to the charger. Then connected the key. Okay. Make sure you're disconnecting the battery from the charger when you are doing the self. When you are doing the self start. Okay. So self is working. Now charges is disconnected, so it is showing full. So when I just started this experiment today, this was showing full when everything was properly connected. That means that can happen either when the battery is full, or secondly when the BMS is dead. It may show disconnected also when the BMS is dead. So I suspected a BMS problem, so that's why I did some 5-6 self, then I connected again and it was showing okay. It was doing charging. I'm removing the key, okay, before connecting the charger here. Should not be done with one hand. Okay. Turn off the charger, turn it on. So now it is charging. So that means BMS everything is okay after 3 weeks of using the battery. In my second video I have shown that the BMS is also involved in the discharge. If you check the other video, discharge happens through the discharge diode bank as well as the BMS, because one separate diode used for ensuring discharge happens only through the diode bank is not put. So in this battery, since it is version 1, the discharge happens both through the BMS as well as diode bank. That's why I'm a bit careful with this. It may go bad also. In the other video which I made for Honda Click vehicle, this one, there I have made sure it is properly done using another diode. Please check that video. And I have made the circuit diagram also in that video how it is done. Yeah, so this is how you check whether the battery is working or not. After 3 weeks it is still working. One small problem I found, this has got digital meter with clock and odometer digital display. So I suspect when this in this dangerous area I have found snakes also, but cats are protecting me. So when this thing becomes, I think when it becomes fully charged, that means the BMS cuts off the charging. At that time I suspect due to some reason this clock gets the digital clock gets reset. That is only disadvantage here. When you put a lead acid battery, that doesn't happen. When you put a BMS battery, that kind of thing may happen. When the BMS cuts off, then you may have problem with the digital clocks and all resetting. That is a disadvantage of this BMS battery in vehicle. If you don't have clock or you have only analog instruments, then it is okay. And there will not be any problem with the self and all. Self start. It will have 3 to 4 times more in the same space, 3 to 4 times and less weight, or same weight as the the lead acid battery. And then the standby time, that means unused, if you keep it unused for 6 months also it is okay, even 1 year it may be okay. Lithium ion battery. Energy density, self discharge is less, cost is some 4 times, that's okay. Then efficiency is high, how much you charge and extract from it, that is high. Then number of cycles is also above 600 compared to 300 in lead acid battery. And that kind of advantages are there. Okay, this is the third battery which I made and tested, lithium ion battery, in this video. Here one very cheap case is there, around 120 Indian rupees as on December 2025 in India. The case is strong as well as the terminals are also good for like 100 amps. Around 100 amps it will supply at 12 volts. So here the very first battery which I had made had some, in my earlier videos I told that it went bad because I kept it in the key on and it discharged. This kind of cells were there, 12 of them. So out of that 8 of them had not leaked electrolyte, but they were discharged to 0 volt. But after charging they were able to retain 4 volt for like 3-4 months, around at least 3 months. But the ones which leaked, the voltage went below the voltage. The ones which leaked, the voltage is not holding up. So one is totally dead, 3 such things are there which are partially dead, and these 2 battery, the light blue ones, was obtained from one drill machine battery pack. So here also 2 of them were good, so that I put in this 8 such battery and 2 such battery. So instead of 9 it is 10. They are having around capacity of 13C and this one is 15C. So this case is quite good, and when we are making battery like this, we are forced to keep things compact. So we cannot take luxury of putting a lot of solder or keeping wires apart and all. So I'll show you. See, inside it is like this. Here the discharge diodes, 7 of them. This diode I explained last time to make sure that BMS is only used for charging. The negative of the pack is connected to 0 volt point of the BMS like this. BMS is 3S 25 volt. Any BMS, good BMS you can use. This is a capacitor, 4700 and 4700 in parallel. That means 2350 microfarad, 35 volt. It's not parallel, it's back to back. That means the negative of both are connected, and then it is connected to the output terminal of the BMS to avoid any transient currents. This is the terminal connection. Two wires have been used, and I don't have spot welder, so that's why this soldering is done. And soldering was done, and I corrected every time to fit in this pack. Now this lid fits just enough, but there is some gap. There is lifting some few millimeters up, so that I will put this reinforced sellotape is there. And this barley paper is used for insulating the battery, and this diode will heat up. This diode and this diode while charging, this diode while discharging will heat up. This is how the setup looks. Many wires are like close to each other, like this is the positive point and this wire is the negative point. So if there is any cut in the insulation, it will be short circuit. So such battery, the water should not collect in this. That you want to make sure, and insulation should also be there. But since the diode is touching this case, that's why I am not making any hole. Otherwise you have to keep the hole in this, and as well as this thing tilted also in the scooter in the side stand, so that the water flows out. It should not collect in this. So this battery can get damaged by a water collecting in this case, over discharge, short circuit, or any physical impact. These 4 conditions can only damage this. And you can also consider using 21700 instead of 18650 lithium ion. You can use 21700, which is having a discharge rate of 20 C and all, and 4.5 Ah capacity. So I think only 3 cells are required. That should be enough. So this is how the setup is. So I have explained the circuit diagram and all in other parts of this video, and I am using in the scooter for nearly a month now, and it is okay. In that one, this diode is not there, but this should also work. This is an improvement actually. This diode, I explained why it is put. The disadvantage will be that this last pack uh, will not, that is B0 and 0 volt and B1 will be always charged 0.3 volts less than the other pack. An advantage is that BMS will not go bad because it is only used for charging purpose. This is how a compact version can be made. It is put like this carefully. There is paper here, this Kapton tape is there to prevent this wire from touching this diodes which heat up. A bit of mechanical skills also is needed. So you have to insert it like this properly, making sure no short is there. I have tested the discharge and all with 80 amps load for continuous 80 amps for 20 seconds and there is no smoke. Okay, I'll pack it off now. So you can also try with 21700 battery. Lithium ion if you use, you'll always get compact design like this. And charging I tested with 6 amp charger, no problem. So this thing will definitely fit in any vehicle. It is just compatible with this proper lithium ion, proper lead acid 3 ampere battery, and the cost is like 3 to 4 times more than this. It took around 4 or 5 days to make it in this proper shape, but once it is made, it will have more discharge charge cycles than this one. It will have less self discharge, which is very important if you are keeping the vehicle unused for a long time. And it is lightweight compared to this. There is no water spillage, acid spillage is not there. So energy density is also high. Energy density is high. Yeah, basically it will last more than this. This will last for like 2 years, it will go bad. This, if you use it properly, 5 years it will last. Okay. Yeah, so this is the fiberglass reinforced tape. It has high strength and resisting pulls, stretches. It will resist stretches. So I have wrapped it like this. No glue applied. Can be cut and used anytime, removed anytime. It's waterproof. So heat will be conducted out via the plastic itself. The discharge diode is here, so that will conduct the heat out via the plastic. Okay, so the testing while doing, one thing is you have to check the capacity by charging it and then discharging it. Other thing is the CCA capacity, cold cranking amp. That means connecting that 80 amp load and at least testing it for 20 seconds. Third thing is you should check whether it is able to hold the voltage for at least 2-3 weeks. That means self discharge should be less. Like that, these 3 voltage, capacity, load testing and all has to be done. That means the battery should not self discharge, should be able to supply the load current and should have sufficient capacity. So this is made via these batteries which had gone bad. The fuse cap is not there. So BMS is doing the protection work, but still it is risky. It is made from scrap batteries. That means it is good enough for a 110cc scooter. Not good for bike actually, good for 110cc scooter. Okay.